So this will finish up section 3.3, and the first two problems that I see ask me to find the average rate of change, and the average rate of change is the slope of a line that connects 2 points on the graph. So when I see the instructions that say find the average rate of change, what that asks me to do is to find the slope of a line that connects 2 points on a graph. So I'm given a function, and I'm given also the x-coordinates of the points. So when I read this function, find the average rate of the change of the function f of x equals x minus 2 squared minus 4 from 1 to 2, what it's asking me to do is to take a look at this graph, which is a parabola. Looks something like this. And what it's asking me to do is find 2 points on the graph, one point that has an x-coordinate of 1, a second point that has an x-coordinate of 2, and find the slope of the line that connects those points. For those of you that are visual, let me just do this visually really quickly. Let me put my y equals on. Let me graph the function x minus 2 squared minus 4. It should be just a nice parabola. What I'm going to need to do is I'm going to find the point with an x-coordinate of 1. I'm going to find a point with an x-coordinate of 2 by peeking at my table. So second table, the point that has an x-coordinate of 1 has a y-coordinate of negative 3. The point that has an x-coordinate of 2 has a y-coordinate of negative 4. So what it's asking me to do, I better blow this graph way up. What it's asking me to do on this graph that goes through the point 1, negative 3, and 2, negative 4, looks something like this. So this parabola that looks something like that. What I'm asked to do here is find the slope of the line that connects the point 1, negative 3 to the point 2, negative 4. My answer is going to be whatever the slope of that line is. The best I can tell you right now that my answer should be negative because that line appears to have a negative slope. So to do problem 24a, I need to figure out the slope of this line. I kind of cheated and used my calculator to get the y-coordinates of the points. Let me not cheat and do the whole problem the way that we're going to need to do it on the test. So visually, the average rate of change I'm trying to find is the slope of this line. And let me just go ahead and figure out the slope of this line. I'm going to get by using the formula y2 minus y1 over x2 minus x1. y2 I'm going to write as negative 4 because that's the y-coordinate of the second point that I found. y1 is going to be negative 3, that's the y-coordinate of the first point. And then in the denominator, x2, which is 2, minus x1, which is 1. This is going to give me negative 4, double negative turns to a plus, plus 3 in the numerator. The denominator, 2 minus 1 is 1. And then I get negative 4 plus 3 in the numerator, which is negative 1. 1 in the denominator. The slope of that line is negative 1. So for 24a, the average rate of change between x equal to 1 and x equal to 2 is negative 1. That don't know if that was the best way to start this section, but this pictorially, this is for each of the next two problems is what we're trying to do. We're trying to find 2 points on the graph of a function that the function isn't a line, and we're going to find the slope of the line that connects those 2 points. And we don't need to do any of this graphically. So I know the answer to 24a is -1. If I didn't use my calculator, I can get the entire problem accomplished. So if this was a test question, what I'd expect you to do is to first, as I go to do 24a, create 2 points. Because the average rate of change is the slope of the line that connects 2 points. My first point is going to be 1 comma something, using the first value that's supposed to be an x, but it doesn't say that's an x. My second point is going to be 2 comma something, using the second number that's given as an x. For each x, I need to get a y. For the first x of 1, I'm going to get the y by plugging in 1 for the x's. I'm going to go f of 1 equals 1 minus 2 squared minus 4. That's going to give me, let me just do it on my calculator. That's going to give me parentheses 1 minus 2 squared minus 4. That's going to give me -3. So the first point has a y coordinate of -3. Then I'll move on to the second point. To find its y, I'm going to find f of 2. To find f of 2, I plug a 2 in for each of those, in for that x, and I'm going to get 2 minus 2 squared minus 4, and f of 2 is going to be what? 2 minus 2 squared minus 4, and that's going to be -4. So that's going to be the y coordinate of my second point. So first I created 2 points, and now I'm going to find the slope of the line that connects the points. Because the average rate of change is a slope. So I'm going to write down average rate of change equals to fraction. For slope, it's y2 minus y1. y2, I'm going to use -4. y1, I'm going to use a -3. I don't know why I put the y2 in a parentheses, but it's not wrong. The y1 definitely want to be in a parentheses because there's a double negative there. And in the denominator, I'm going to do x2 minus x1, which is 2 minus 1. I've already done this. And I can say my average rate of change is the numerator divided by the denominator. This parentheses I didn't need, I just dropped it. This double negative I changed to a plus. And then in the denominator, 2 minus 1 is 1. This simplifies to be -1 over 1 because -4 plus 3 is -1. That fraction reduces to -1. So my answer to 24a, the average rate of change on this graph for those two values of x is -1. We'll go on and do 24b. 24b gives me the same function, asks me to find the average rate of change between two different values of x. First thing I need to do is create points. The x coordinate of the first point is 3. The x coordinate of the second point is 5. To get the y coordinates, I'm going to plug 3 in for the x. The first y coordinate, I'm going to go f of 3 equals to 3 minus 2 squared minus 4. And that's going to be parentheses 3 minus 2 squared minus 4. That's going to be -3 for its y coordinate. I need to get a y coordinate for the second point by plugging in 5 for those x's. So I'm going to do f of 5 equals 5 minus 2 squared minus 4. Do that on my calculator as well. So parentheses 5 minus 2 squared minus 4. That gives me 5. So now I have the 2 points that I need, and once I have 2 points, I can find an average rate of change by finding the slope of the line between those 2 points. So my average rate of change will equal y2 minus y1 in the numerator, which is 5 minus negative 3, and then x2 minus x1 in the denominator, which is 5 minus 3. The numerator, this is going to come out to 5 plus 3. That double negative goes positive. And that 5 plus 3 is going to turn into an 8. The denominator, 5 minus 3 is 2. So I get 8 over 2, which is going to be 4. So my answer to 24b, I can just write 4, or I can write the average rate of change is 4. You don't need to write the average rate of change if you don't care to. You can just put down the number. I guess you can write m equal to 4 because it's a slope. It would kind of be wrong to write x equal to 4 because here x is 3 and x is 5. So 25 should work the same way. You have a part A and a part B. I'm going to move on and do 26, and you might be able to do 27 without me doing 26, so give it a go if you can. For 26a, I need to create 2 points. I'm finding the average rate of change between x equal to negative 3 and x equal to negative 2. I have 2 x values. For each x, I need to get a y. For each x, I'm going to get the y by plugging in my value of x into the function. For the first x, I'm going to plug negative 3 in for the x's. I'm going to get negative 3 cubed in a parentheses minus 2 times negative 3 plus 1. So my first y is going to be negative 3 up arrow cubed minus 2 parentheses negative 3 plus 1. My first y is going to be negative 20. My second y, I need to plug negative 2 in for x. And that's going to be negative 2 cubed minus 2 times negative 2 plus 1. Again, I'm just going to cheat or be lazy or maybe be more accurate. My second y is going to be negative 3. My average rate of change is going to equal to y2, which is negative 3, minus y1, which is negative 20, over x2, which is negative 2, minus x1, which is negative 3. I'm going to do this all on my calculator. To do this on my calculator, the entire numerator and the entire denominator need to go in separate parentheses. So real quickly, just to save mistakes, on my calculator, numerator, parentheses, and then negative 3 minus parentheses negative 20. Close out the parentheses on the negative 20, close out the parentheses for the numerator, and then divided by parentheses for my denominator, negative 2 minus parentheses negative 3, close out the parentheses for the negative 3, close out the parentheses for the denominator, hit enter. My answer to 26a is just the number 17. For part B, I need to create 2 points, and the first point in part B is going to have an x coordinate of negative 1. I'll need to figure out the y coordinate. The second point in part B has an x coordinate of 1. To find my y's for part B, the first y I'm going to get by plugging negative 1 in for x by going negative 1 cubed minus 2 times negative 1 plus 1. I think that comes out to 0, but I don't know that for a fact. So I'm going to get this y by going negative 1 up arrow 3 minus 2 parentheses negative 1 plus 1. I get 2. Luckily I didn't really. Yeah, I guess I can live with that. And then the second y I'm going to get by plugging in 1 for x, which is I'm going to go f of 1 equals 1 cubed minus 2 times 1 plus 1. That one might be 0. I don't know. So second y parentheses 1 cubed minus 2 parentheses 1 plus 1. I get 0. So those are my 2 points. The average rate of change is the slope of the line that connects those 2 points. So now I'm going to find my average rate of change. I'm going to form a fraction. In the numerator, it's y2 minus y1, which is 0 minus 2. In the denominator, it's x2 minus x1, which is 1 minus negative 1. The numerator, 0 minus 2 is negative 2. And in the denominator, the double negative turns positive, so you get a 1 plus 1 in the denominator. The numerator comes out to a negative 2. So this whole thing comes out to be negative 2 in the numerator, divided by 2 in the denominator. That reduces to negative 1. The answer for 26b, the average rate of change, is going to be negative 1. You can write that as words, or you can just write down the number. If you care to write the words, it's fine. So my average rate of change, average of rate of change, is negative 1, because a fraction negative 2 over 2 reduces to negative 1. All right, so your 27 should work the same way. We have a couple word problems left, and there's a 28, 29, and 30. Let me just do problem 29 because I think it's kind of interesting. And these don't come on the test, but why don't you just kind of throw this into your notes real quickly. So I'm given a pretty horrible function. The function a of x equals this mess approximates the blood alcohol concentration in a 170-pound woman x hours after drinking 2 ounces of alcohol on an empty stomach. The graph of this function is for the first 5 hours as drawn below. The x-coordinate represents how long it's been since the woman had her 2-ounce drink, and the y-coordinate is her blood alcohol concentration. So this first point, 0, 0, it says at time 0, before she actually took a drink, she had 0% blood alcohol. The second point that I read, 1.85, 0.091, says at 1.85 hours, so just under 2 hours, her blood alcohol content is 0.091, and that would be illegal to drive in Arizona because I think 0.08 gets you a DUI. And then after 5 hours, it's down to 0.03. I'm sure I didn't make this up. I stole this from the internet somewhere and thought it was interesting. First question is to find the intervals where the graph is increasing and decreasing and interpret your results. Usually when we're dealing with increasing and decreasing functions, I start off writing negative infinity on the far left edge of the right x-axis, positive infinity on the far right edge of the x-axis, and the turning points, x-coordinates, between those infinities. This function is only valid for the first 5 hours after the woman took her drink. And to get started, instead of putting the infinities on my x-axis, I'm going to put the x-coordinate of this point, which is 0 hours, the x-coordinate of that point, which is 5 hours, and the x-coordinate of the turning point, which is 1.85 hours, and throw those on my x-axis for my increasing and decreasing intervals. I'm going to create 2 intervals. The first interval is going to be 0 to 1.85, all round parentheses for increasing and decreasing. The second interval is going to be 1.85 to 5. In the first interval, as I move from left to right, the graph is getting higher. This is going to be an increasing interval. In the second interval, as I move from left to right, the graph is getting lower. That's going to be a decreasing interval. So when I go to answer problem 29a, I'm going to say the increasing interval is between 0 and 1.85 hours. And the decreasing interval is between 1.85 and 5 hours. And it says interpret the result. That means for the first 1.85 hours, the alcohol concentration in the blood is going up, and then it reaches its maximum concentration. And if you don't take another drink, it'll start going back down, and eventually it'll be out of your body. But at 1.85 hours, you wouldn't be legal to drink. So for the first 1.85 hours, the alcohol concentration is going up. It reaches its maximum, and then it goes back down. Didn't leave myself a lot of room here. Then it drops off. I don't have enough room to write something very nice. But something like that would be fine. So the first 1.85, almost 2 hours, the alcohol concentration goes from nothing to its maximum of 0.091, and then it decreases over time. So what was the maximum part B, what was the maximum blood alcohol concentration? The maximum blood alcohol concentration is the y coordinate of the maximum point. So the maximum blood alcohol concentration is 0.091. And when did it occur? It occurred at 1.85 hours. And that's all we really need to do for problem 29. It won't sneak its way onto the test, so it's not necessarily the most important thing in the world, but it's kind of nice to know, and it's an interesting problem. All right, so a good stopping point for this section.